Today we're going to look at what happens whenever we dilute acids and alkalis. Now dilution, that just means lowering the concentration. And one way that we can do this is by adding water. So we can add water to a solution that already exists. If you add water to it, it will get more dilute. Just like if you had diluting juice, add more water to it, it tastes less strong. And the other way you can dilute a solution would be actually just to add less solid, but that's not really dilution, that's just making a lower concentration. Dilution is specifically adding water. And this is something that has an effect on acids and alkali because it affects pH. So dilution affects pH. Now the reason for this is pH is related to the concentration of hydrogen ions, H plus ions. And so if you dilute a solution, the concentration of this is going to go down. So dilution lowers the concentration of H plus, and what this does is it increases pH, because the more H plus, that means the more acid we have. So if we have less of this, it means your pH must go up. So the relationship is if H plus goes up, then pH goes down. Or H plus goes down, then pH goes up. So dilution always makes the pH of an acid go up, because dilution lowers the concentration and the pH is going to go up. The opposite happens with an alkali. But firstly, what we'll do is we'll look at an experiment to show that pH is affected by dilution. Now with this, the dilution experiment, all you need is a set of test tubes. Oh, that's not a very good one, is it? A set of test tubes. And in each test tube, we have some universal indicator. Now what we do is we add some strong acid in here. And we fill it up 10 milliliters. So every experiment is going to have 10 milliliters. And because it's a strong acid, the universal indicator is going to be red. What we do is we transfer some of that into here. So we add 1 milliliter of that. So we have 1 milliliter of that. And then we top it up to a total of 10 milliliters here. So 1 milliliter of that, still going to be red to start with, and then we add some more water. Now what starts to happen is that the colour changes a little bit. So it's no longer pure red, it's more of a red-orange colour. And then we do the same thing again. We add 1 milliliter from here, and we top it up. And instead of it being reddy orange, it'll be fully orange. Well, that one's not looking so reddy orange, but you know what I mean? It's red orange. We can do it again. We can keep going, and 1 ml, top it up, and this time, yeah, we'll have some orangey colour, but it'll start turning a yellowy orange. So it's yellow and orange all together. So you can see that, and then the final one, we can do it, would be, when we diluted it, it would be all yellow. And we could, for a final one, do it again. And this time, we've got the yellow, but it'll be yellowy green. Ooh. Yellowy green. Sorry, it's not very clear. Yellowy green colour. The reason for that is because the pH is changing. So we started at pH 1, and remember, each one, we're diluting it 10 times because we're adding 1 and making it up. So we started at pH 1, we do the dilution, so it's 10 times less concentrated, pH 2, pH 3, pH 4, pH 5, pH 6. Now, you'd think, oh, maybe we can keep going on and on and on and on and on, and every time the pH is going to keep going up and up and up. But if we start with an acid, we cannot turn that into something that's neutral. We cannot turn it into something that's an alkali. So diluting can only make it weaker. But it's still an acid. And so if we start with a strong acid and we do dilution, we can do it to about 6.9 would be the final one. And it would still look very yellowy green. Now if instead of drawing it in colours, if we used a pH meter and did this dilution and then plotted a graph of our results, we would see if this is pH and this is dilution and this is for an acid, we would see that the pH, it might start at 0, it goes up, and then it goes up. And this value here, we've got a dotted line that it never crosses, that would be pH 7. So when we dilute an acid, what's happening is that the amount of H plus ions is getting less, and what that does is it makes the pH go up each time. But we can never get to 7 because diluting makes it weaker, but it's still an acid. And so we start at the pH low. It could start at 0, could start at 1. It goes up and then gets a flat line just below 7. Now if we do the same thing, but with an alkali, well, it's just the opposite way around. So we have, for an alkali, if we start pH, maybe we start at pH 14. They're strong alkali. It would start being purple or dark blue. And if we did the same process with each one, doing the dilution, we would get changing colour slightly each time, so getting lighter blue, and then eventually ending up a blue-green colour. And so, again, so maybe if we started at pH 11, we then go to 10, to 9, to 8 by diluting it. But again, you might think, oh, we can keep going, but we can only go down to about 7.1 because dilution makes it weaker, but it's still an alkali. If it's still an alkali, it has to be above pH 7. Now what's happening here is that the concentration of OH minus is what's going down. And the concentration of OH minus, if it goes down, then pH goes down. Or you could say if this goes up, then pH goes up. So remember, the H plus ion, if it went down, then pH went up. But the hydroxide ion, if it goes down, then the pH goes up. And if we plot a graph of dilution for an alkali, we would see it's starting high, same shape graph, but it would curve down, a nicer curve if we can, like that, and again we would have a horizontal line that it never touches, and that would be pH 7. So it might start at pH 14, 12, 10, anything quite high for a pH, but it never gets below 7. Never gets below 7, it stays there above it because it's always an alkali. So what we saw today in this lesson was how dilution affected pH. Now, so we saw for an acid that if we dilute it, so if we keep adding water to it and making it less concentrated, the pH goes up. And the pH can get close to pH 7, but it'll never be pH 7 because diluting makes it weaker, but still an acid. For an alkali, again, this time the pH goes down as we do dilution. And that's because dilution makes it weaker, it's still an alkali, which means that our pH can drop, but it can never go below 7. And that's because as the hydroxide ion concentration decreases, pH decreases. Now the final point you might wonder is, well, what happens for a neutral solution? What happens if you add water to a neutral solution? Well, water is neutral, so it is pH 7, and neutral is pH 7. So add water to a neutral thing, just pH stays at 7. Doesn't have any effect because both of them are neutral. So water has an effect on acids, it has an effect on alkalis, but it doesn't do anything to neutral. So that was us looking at the effect of diluting acids and alkalis on the pH. Thank you for your attention.